evening and welcome to Tinkering with Edkelar. This episode is another combo. That is, it features multiple very similar devices. In this case, HP logic probes. As you will see, these are very simple designs, so cleaning them and performing a function check on each of them is rather quick. This is why I decided to cover all of them in the same video. Oh, and also, I managed to get one of the extra rare sets that HP sold, including the snazzy carry bag. They were not cheap, but when the complete set came up for grabs for about the same price as one of the more rare probes, I just had to grab it. I think I made quite a good deal here. First off, what's in the bag? We got the current tracer, logic probe, logic pulsar, as well as the logic clip and a few test clips with grounding wires. Let's start with the actual logic probe, model 454A. This one comes with a few nicks in the stickers, but at least they are still attached and not peeling off. The business end has a very sharp tip and the rear features a lead for power that ends in two connectors. They can connect to anything that has a similar pin like the test clips. For breadboard use, I usually connect them to jumper wires directly. There have been versions that have a BNC connector on here instead. Those would connect to the BNC power socket on some of the other logic test equipment, like the 1600 logic analyzer or the breadboard I showed a few videos before. It comes apart by unscrewing the probe tip. Note that there have been accessories sold with different probe tip options, but these are even more rare these days. The red indicator cover just slides off. The aluminium extrusions that make up the case also just slide apart. The bottom one needs to slide out first because the top one needs to lift off the buttons and ground pin. As you can see, there is not much going on besides the TTL CMOS switch and the memory clear button. The indicator is an incandescent bulb, while the memory indicator is an LED. Mixed signals indeed. To my knowledge, newer revisions have replaced the bulb with another LED to minimize the supply current draw. I clean up the outside of all the case parts and the wire with IPA. The residue looks like nicotine again. At least there is no noticeable smell to them. Assembling the probe is the same as the disassembly, only in reverse. The upper case part is first, then sliding the lower case cover in again. Adding the indicator cover and screwing on the tip. Done. Let's look at the circuit for a moment. Pretty much all the processing happens inside the custom chip U1. The external components are a rather crude voltage regulator on one end, which also protects against overvoltage and polarity mishaps. On the other end, the transistor Q3 drives the bulb. And on the probe side, we have a bit of an RC element. This will also protect the chip with a 24 kilo ohm resistor, but allows transients to bypass over the 130 ohm path via a tiny capacitor. To make sure it is working as expected, I run through the performance checks in the manual, at least as good as I can without the extra fast pulse generators. The indicator light should glow half bright for invalid signals, which includes a floating probe tip. It should be off for logic low and fully on for logic 1. This tri-state validation is already helpful since it does resolve the typical tolerances that TTL or CMOS gates have, so it should be easy enough to detect what I know as brown signals. Both the TTL and CMOS levels work as the manual says, either spot on or at least within tolerance. Nice! Faster signals, up to 80 MHz TTL or 40 MHz CMOS, will be shown with a blinking indicator. And the memory function also works. The signal latches on whenever a change on the input is detected. You clear it by pushing the button. That way you can see if there are short pulses happening, down to about 1 microsecond. Up next, the logic pulsar, model number 546A. It has the same case as the logic probe, so the same procedure to get into that. And again, not much to talk about on the inside. The only element to the outside here is the push button, which also supports a lock position, so it's not just a standard run-of-the-mill button. Again, cleaning the power line. Same as for the probe, there were versions with BNC connectors around. And also cleaning up the contacts for the switch, just because. Assembly is also exactly the same as for the logic probe. The circuit itself has a few more components than the probe had. In the center is, again, a custom chip. This one will decode the Morse code style user input and drive the output accordingly. On the supply side, there is a simple voltage regulator. On the output side, Q1 and Q2 are switching the probe to either ground or the supply rail, which is passed through the chip. This is done to give it a current sense capability. That means that the logic pulsar can create a low and a high level, while under the normal idle condition, the tip is high impedance and should not cause any input just by touching a test point. The pulsar always creates low-high pulses on the output. It pulls the tip to ground first and then to the supply rail. It is short-circuit protected and should shut down if the current exceeds the built-in limit. The pulses, both 0 and 1, are about 10 microseconds in width. The button controls how many and how frequently they are triggered. According to the manual, the current provided should be enough to override common output stages. I'd still be careful though. Testing the Morse code feature. Nice! But the guide printed on it is absolutely required. I doubt that these are easy to remember. And the third pen style item, the current tracer, model 547A. This one is slightly different in that it features a non-contact probe with an isolated tip. Said tip is also soldered in place, so it's the indicator cover that unscrews here. This one has by far the most components crammed into that little form factor. And one more time, cleaning the power cord. And assembling in reverse order. The only interface element here is the sensitivity adjustment potentiometer. According to the manual, the range is from 1 mA to 1 amp. The circuit is thus also quite a bit more complicated. The probe in this case is a little magnetic sensor coil, should be very similar to a tape or disk drive head inside the tip. It feeds directly into a transistor for amplification, which goes into 2 amplifier stages from there even. The adjustment potentiometer adjusts the gain of that first input stage. The amplifier stages that follow include the peak detection circuitry. By charging capacitors directly and discharging them via resistors, the probe stretches pulse lengths to visible times for the indicator lamp. And testing a signal via a resistor. Works. The last part of the set is the logic clip, model 548A. This one is quite boring, I'm afraid. The manual explicitly says nothing to repair inside, so there is also no clear way of opening the case without any damages. It is clearly 2 half shells snapped together, but I don't want to break it apart. It might literally break. Gently prying didn't yield any idea on how to take it apart either, so I'm just cleaning it and adding a tiny amount of grease in the rubbing surfaces. To show the clip, I'm wiring up a counter on a breadboard. The general idea is to just clip the tester to the IC in question, which can be any dip case up to dip 16. There is also no need for a supply voltage. The circuit inside will just leach to the highest and lowest voltage. So as long as the supply pins are covered, it should be fine. If that doesn't work, for example on 3V low power CMOS, the clip provides an external power pin on top where you can connect VCC with a dedicated lead. Ground is still going to flow through the lowest pin under test though, but the LEDs are then driven from the external input and parasitic power consumption will be next to zero. I found a schematic and an exploded picture in an old HP journal, link in the description. It shows that the clip is pretty much just a custom IC and a set of LEDs, nothing else. The IC pretty much uses diodes to rectify the input onto the internal supply rails and compares the input to switch on the LEDs with a constant current source. The external supply, if needed, will be connected to the VCC bus via another diode. The little microclips that came with the set are in good condition, only needing a tiny bit of cleaning. But they move a bit stiff, especially when pushing down off-center, and since the wires hook up dead center, they are hard to operate. I added a tiny amount of silicone grease into the mechanism, wiped off the excess, and now they work fine in normal operation too. The final bit is to take care of the carry case. The outside is a bit dusty. Nothing a quick wipe down with IPA can't fix. It has a few minor scuff marks on the narrow side and somebody wrote a number on one side with a Sharpie. That number doesn't budge with a gentle IPA rub and I don't want to use too aggressive cleaners. I might rub off the finish of the case. Notice the shag carpet on the inside that screams 1970s. Groovy! And a last minute addition, I found the accessory probe tip set. Woohoo! It is missing the angled tip though, but the other items are still here. First, the typical wipe down. And here we go. First option, a crocodile clip tip. Second option, an adapter for breadboard connectors or the regular test clips. Third option, an adapter for a flexible tip. Not sure if I'm missing something here, but the wire with the bent hook on one end screws into that. And that's it, a test kit for logic level fault analysis ready to go. On the go. I have been using it here and there already and it is certainly still useful for some things. Which is probably why these fetch a very steep price on eBay these days. If you are looking for some, I recommend a safe search. Occasionally they pop up for prices that are at least affordable. I hope you enjoyed this episode. See you next time! The outside is a bit dusty. Nothing equip wipe down. Yeah, wipe down.